There's a lot of stuff in this chapter that really is more just kind of background for you. And so I'm just going to tell you, I'm not going to quiz you on anybody's name or when they lived, right? But we're going to talk about these people. I just think it's helpful to have heard about where some of this stuff came from. So radioactivity was discovered in 1896 by Antoine Henri Becquerel. And he was looking at phosphorescence. So phosphorescence is when something is exposed to sunlight and then gives off a greenish glow in the dark. So a lot of the glow in the dark, like frisbees and stuff, that's how they do it. It's phosphorescence. There are naturally occurring things that do this. I remember seeing one of these when I was on vacation with my family in Minnesota. There was an old stump by the cabin, and it had been rotting and stuff. And you go out to use the outhouse at night, and you're like, what's glowing in the woods over there? And you go over there, and the inside of this stump is just glowing. It's phosphorescing. So in the process of decomposing, it had formed some compounds that phosphoresce. So Becquerel was like, well, what are these things? What's going on? How does it do this, right? Curious scientist. His hypothesis was that greenish glow was associated with the emission of X-rays. X-rays are invisible. And so what he did is he took potassium uranyl sulfate crystals, which will phosphorus. He exposed them to sunlight, and then he put them on a photographic plate that was covered up so that no light could hit it. And the plate then gave an image like this. There were dark areas where the crystals had been. So something given off by the crystals was exposing the photographic plate. And his hypothesis was that this was X-rays. So his hypothesis appeared to be correct. He presented his results to the French Academy of Sciences. Later he discovered that he had been wrong, and he retracted his results. And this was because he found a dark exposure spot on that film, even when the crystals hadn't been exposed to sunlight and weren't phosphorescing. So they weren't glowing, and they still exposed the photographic plate. So then he's like, oops. This is actually a very normal thing in science. Being wrong in science is not a shameful thing. You have to kind of go out on a limb to say, well, I think this is correct, right? And you look for evidence, and you find evidence, and all of this points to that conclusion, and so you share it with people. And then later, you may get some new information that shows that your hypothesis wasn't correct. Unlike politicians, you don't just stand with what you said before. I'm not going to be a flake. I'm not going to waffle back and forth. Well, you're also not going to be an idiot, right? We've got new information. So then we change our conclusion. And that's what science does. So, you think back to the early COVID days, at first the CDC or whatever it was came out and said, don't use masks, don't wear masks, right? Because they wanted to save them for hospitals. There was a limited supply. And they had no evidence that COVID could be transmitted through the air. So they didn't know that it would do any good, and it could be wasteful. Well, then, a month or two later, they came out and said, no, do wear masks, right? And people are like, you guys don't know what you're talking about. Well, no, they didn't know what they were talking about, but they were sharing with us what they learned as they learned it, right? And so the reason they reversed their position on masks is because new evidence came up, new information, and so they realized that the first recommendation was not correct. And then, people just crucified them in the public media because, that's not how normal people act. But this was not a normal situation. This was science. Nobody knew what was going on, right? Nobody knew. And so you can't just make a policy and stick with it because you don't want to admit you were wrong. That could kill lots and lots of people. So that was one of the really big things that stressed me out about COVID, was realizing that most of the country has no clue how science works. Anyway, that was a side tangent. So he retracted his results because he realized that the crystals themselves were doing something that exposed the photographic plate. It was not the phosphorescence. And so, he was like, well, what is this something? He called them uranic rays because they came from crystals with uranium. Marie Curie, you've probably heard of her. She was one of the first women in France to do doctoral work in science. And in her studies, she found 2 new elements. She was searching for other substances that also emitted these uranic rays. And in the process of doing that, she found 2 new elements. And back then, if you discovered an element, you got to name it. Now there has to be a committee and everything. But the first one she named polonium for her home country of Poland, where she was originally from. And the other one was radium, and that was named for its high level of radioactivity. That radium is so radioactive, it actually glows and emits heat. And that's what the kind of stereotype people have, like from cartoons and stuff. Well, if it's radioactive, it glows in the dark, right? And so, don't eat that because you're going to become radioactive or whatever. Most radiation doesn't do that. Radium does. This is a picture of a wristwatch. They used to use radium in paint to make glow in the dark numbers and stuff on your watch. Radium's highly radioactive. So people are walking around with, little bits of radium strapped to their wrists. Not a good idea. Not a good idea. Anyway, I think Curie thought uranic rays was a dumb name. Anyway, she changed it to radioactivity, which is what we call it today. She got the Nobel Prize along with Becquerel and her husband Pierre in 1903, Nobel Prize in Physics for discovering radioactivity. And then later in 1911, she got the Nobel Prize in Chemistry for discovering 2 elements, polonium and radium. And it's very, very unusual to get 2 Nobel Prizes and in different subjects. So very, very impressive. This is a picture of her with her daughters.